NEC Section 645.5 addresses the use of Type TC cables within cable trays in information technology rooms, specifying conditions under which direct connections to equipment are permitted without requiring a junction box or receptacle. The conditions for this allowance are: firstly, the cable length must not exceed 15 feet. Secondly, the cable must be marked with TC/CDRS. Thirdly, the cable's usage is limited to branch circuits supplying portable equipment or data processing equipment. The marking TC/CDRS/GY/L has distinct meanings. TC signifies Type TC cable specifically intended for information technology applications. CDRS stands for Communication Data Rated System. GY indicates the cable jacket's gray color. That denotes a limited energy circuit, which typically applies to data and communication circuits. An inspector's interpretation that all fixed equipment necessitates hardwiring or a box with a receptacle does not align with NEC Section 645.5, which explicitly provides an exception for direct connections when using Type TC cables under the outlined conditions. Several code references support the permissibility of direct connections in this scenario. NEC Section 645.5 itself allows for direct connections to equipment using Type TC cables, provided the specified conditions are met. NEC Section 645.2 outlines the specific requirements for cable trays installed within information technology rooms. NEC Section 645.5 defines fixed equipment as equipment either fastened in place or provided with permanent means of support, and importantly, this definition does not supersede the allowances provided by 645.5. BT1 Type TC cables are utilized as described. Based on the NEC, an installation involving Type TC cable in a cable tray within an information technology room, where the cable does not exceed 15 feet, is marked TC/CDRS, and directly connects to data processing equipment, complies with NEC Section 645.5. This installation does not require hardwiring or a box with a receptacle. Consider this scenario for clarity. An information technology room houses several equipment racks. A cable tray runs from the load center above these racks. Type TC cable, specifically a 12/3 cable, is used. The cable's length from the tray to the connection point is kept under 15 feet, adhering to 645.5. This cable is marked TC/CDRS/GY/L. The cable exits the tray, extending approximately 12 inches to a 20 amp twist lock female cord cap connecting to the information technology equipment. The inspector, in this case, cites fixed equipment as needing hard wiring or a box with the receptacle on the tray. However, the interpretation of 645.5 is that it permits this installation. To further clarify, let's break down the NEC articles. Article 400 covers flexible cords and cables, their uses, and construction requirements. In the situation described, Article 400 might not directly address the TC/CDRS marking, as TC cable falls under Article 336, which covers Type TC tray cable. The TC/CDRS marking indicates the cable's suitability for cable tray use and communication data rated systems. The inspector's concern about fixed equipment stems from a general understanding that fixed equipment often requires permanent wiring methods. However, Article 645, specifically addressing information technology equipment, provides exceptions to this rule. 645.5 is one such exception, allowing the use of TC cable for direct connection to equipment under specific conditions, overriding the typical requirement for hardwiring or a box with a receptacle. The key here is understanding the scope and intent of Article 645. It recognizes the unique electrical needs of information technology equipment and provides flexibility in wiring methods to accommodate those needs. The 15-foot limitation on cable length is a safety measure to prevent long runs of exposed cable, reducing the risk of damage or fire. The TC/CDRS marking ensures that the cable is suitable for use in cable trays and can handle the data communication requirements of information technology equipment. The permission for direct connection eliminates the need for additional boxes or receptacles, simplifying the installation and reducing potential points of failure. To build a stronger case, gather documentation supporting the interpretation of 645.5 Tor. This might include the cable manufacturer's specifications, which should clearly state the cable's TC/CDRS rating and suitability for use in cable trays and data communication applications. It's also useful to have a copy of the NEC readily available to point out the specific language of 645.5 Tor. When discussing this with the inspector, focus on the following points. Firstly, the installation meets all the requirements of 645.5 Tor, including cable type, cable length, and equipment type. Secondly, Article 645 provides specific exceptions to general wiring rules for information technology equipment. Thirdly, the TC/CDRS marking indicates the cable's suitability for the intended application. Fourthly, the direct connection method simplifies the installation and reduces potential points of failure. Fifthly, the 15-foot cable length limitation ensures safety. To further support the interpretation, consider contacting a qualified electrical engineer or a code expert for a second opinion. A written statement from an expert can carry significant weight in resolving the dispute with the inspector. Furthermore, be prepared to discuss the potential safety concerns that the inspector might raise. For example, the inspector might be concerned about the potential for the cable to be damaged or disconnected. Address these concerns by explaining the measures taken to protect the cable, such as securing it to the cable tray and using a strain relief at the connection point. Also, emphasize that the twist lock connector provides a secure and reliable connection. In summary, the NEC allows for direct connections to equipment using Type TC cables in information technology rooms under specific conditions outlined in 645.5 Tor. The TC/CDRS marking indicates the cable's suitability for this application. The 15-foot cable length limitation ensures safety. The direct connection method simplifies the installation and reduces potential points of failure. By understanding the code requirements and providing supporting documentation, you can effectively address the inspector's concerns and ensure that the installation is approved. Consider this detailed breakdown to strengthen the case. Explain the role of cable trays in information technology rooms. Cable trays are designed to support and manage cables in an organized manner. They provide a safe and efficient way to route cables throughout the room, reducing the risk of damage or interference. Explain the benefits of using Type TC cable in cable trays. Type TC cable is specifically designed for use in cable trays. It is resistant to moisture, chemicals, and abrasion, making it suitable for the demanding environment of an information technology room. Explain the importance of proper cable management. Proper cable management is essential in information technology rooms to maintain airflow, prevent overheating, and facilitate troubleshooting. Explain the advantages of using twist lock connectors. Twist lock connectors provide a secure and reliable connection that is less likely to become disconnected than other types of connectors. If the inspector remains unconvinced, consider requesting a formal interpretation from the NEC. The NEC is a process for obtaining interpretations of code requirements. A formal interpretation can provide a definitive answer to the question and resolve the dispute with the inspector. In addition to the above information, consider the following points. The NEC is updated every 3 years. Make sure you are using the latest version of the code. The NEC is a complex document. It is important to consult with a qualified electrical professional to ensure that you understand the code requirements. The inspector has the final say in whether or not an installation is approved. However, you have the right to appeal the inspector's decision if you believe that it is incorrect. When communicating with the inspector, be polite, respectful, and professional. Explain your position clearly and concisely, and be prepared to answer any questions that the inspector may have. By following these guidelines, you can increase your chances of resolving the dispute with the inspector and getting the installation approved. Remember to document all communication with the inspector, including the date, time, and subject of the conversation. Keep copies of all relevant documents, such as the cable manufacturer's specifications, the NEC, and any correspondence with the inspector. This documentation will be helpful if you need to appeal the inspector's decision. Furthermore, consider the broader context of electrical safety in information technology rooms. Explain how the direct connection method, when implemented correctly, can actually enhance safety. By eliminating unnecessary junction boxes and receptacles, you reduce the potential for loose connections, exposed wiring, and other hazards. Emphasize that the goal is to create a safe and reliable electrical system that meets the needs of the information technology equipment. If possible, provide examples of similar installations that have been approved by other inspectors. This can help to demonstrate that the interpretation of 645.5 TOR is not unique or unreasonable. It's also worth noting that some jurisdictions may have local amendments to the NEC. Check with the local electrical authority to determine if there are any specific requirements that apply to information technology room installations in your area. Be aware of any potential conflicts of interest. If the inspector has a personal or professional relationship with someone who would benefit from the rejection of the installation, this could raise concerns about bias. If you suspect a conflict of interest, you may want to consider requesting a different inspector. And finally, remember that the ultimate goal is to ensure the safety of the electrical system and the people who will be using it. Be willing to work with the inspector to find a solution that meets the code requirements and addresses any safety concerns. A collaborative approach is often the most effective way to resolve disputes and achieve a positive outcome. Think about the specific type of information technology equipment being connected. Is it truly portable, or is it more accurately described as relocatable? The distinction can be important, as 645.5 TOR specifically refers to portable equipment. If the equipment is easily moved from one location to another without requiring significant disassembly or specialized tools, then it is more likely to be considered portable. However, if the equipment is heavy, bulky, or requires special handling, then it may be considered fixed equipment, even if it is not permanently fastened in place. Consider the impact of the installation on the overall electrical system. Will the direct connection method overload the circuit or create any other electrical hazards? Make sure that the circuit is properly sized and protected to handle the load. Also, consider the potential for future expansion. Will the direct connection method limit the ability to add more equipment to the circuit in the future? It's important to plan for future needs to avoid having to make costly modifications later. Review the cable's ampacity rating. Ensure the 12/3TC cable has sufficient ampacity for the 20 amp circuit and the connected IT equipment. Overloading the cable could create a fire hazard. In addition to cable ampacity, verify the voltage drop. Excessive voltage drop can cause equipment malfunction or damage. The 15-foot length helps minimize voltage drop, but it's still good practice to calculate it, especially with sensitive IT equipment. Explore the history of 645.5 TOR. Understanding the reasons behind this specific allowance can provide valuable context when discussing the code with the inspector. The exception likely originated to address the unique power distribution needs and rapid reconfiguration requirements of data centers. Consider the long-term maintenance implications. While the direct connection simplifies the initial installation, think about how it will affect future maintenance and troubleshooting. Ensure that the connections are accessible and that the cables are properly labeled for easy identification. Also, establish a regular inspection schedule to check for any signs of damage or wear. Explore alternative wiring methods. If the inspector remains adamant about requiring a box with a receptacle, explore alternative wiring methods that would still comply with the code while minimizing disruption to the installation. For example, you could use a short length of flexible metal conduit FMC to connect the cable to a receptacle mounted on the cable tray. This would provide a degree of flexibility while still meeting the inspector's requirements. If all else fails, consider seeking a formal variance from the local electrical authority. A variance is a written authorization to deviate from the strict requirements of the code. Variances are typically granted when strict compliance with the code would be impractical or would create an undue hardship. However, you will need to demonstrate that the proposed alternative wiring method provides an equivalent level of safety. Finally, remember that the electrical code is not just a set of rules, it is a living document that is constantly evolving to reflect new technologies and best practices. Stay up to date on the latest code changes and interpretations to ensure that your installations are always safe and compliant. And do not hesitate to seek guidance from qualified electrical professionals when you have questions or concerns. The TC/CDRS cable marking is crucial. Ensure the cable marking is legible and clearly visible to the inspector. Faded or obscured markings can lead to rejection. Explain the grounding and bonding requirements. Proper grounding and bonding are essential for electrical safety. Make sure that the cable tray and all connected equipment are properly grounded and bonded in accordance with the NEC. Verify the overcurrent protection. The circuit breaker or fuse protecting the circuit must be properly sized to protect the cable and equipment from overloads and short circuits. The overcurrent protection device should be readily accessible and clearly labeled. Consider the environmental conditions. The information technology room may have specific environmental requirements, such as temperature and humidity control. Make sure that the cable and equipment are suitable for these conditions. Also, consider the potential for exposure to moisture or corrosive substances. Explain the labeling requirements. All electrical equipment and wiring must be properly labeled to identify its purpose and voltage. The labeling should be clear, legible, and permanent. The label should be securely attached to the equipment or wiring. In addition to the above information, consider the following specific details about the installation. The type of twist lock connector being used. The twist lock connector should be rated for the voltage and current of the circuit. The twist lock connector should be listed by a recognized testing laboratory, such as UL or ETL. The method of securing the cable to the cable tray. The cable should be securely fastened to the cable tray to prevent it from moving or becoming damaged. The cable should be supported at intervals that comply with the NEC. The method of providing strain relief at the connection point. Strain relief should be provided at the connection point to prevent stress on the cable and terminations. The strain relief should be suitable for the type of cable and connector being used. By providing this level of detail, you can demonstrate to the inspector that you have carefully considered all aspects of the installation and that it is safe and compliant with the NEC. Finally, consider engaging a third-party inspection agency. A third-party inspection agency can provide an independent assessment of the installation and identify any potential code violations. A favorable report from a third-party inspection agency can be very helpful in resolving disputes with the local electrical inspector. Remember that the goal is to ensure the safety of the electrical system and the people who will be using it. Be willing to work with the inspector, seek guidance from qualified electrical professionals, and provide detailed documentation to demonstrate that the installation is safe and compliant with the NEC. This detailed explanation should provide a solid foundation for resolving the dispute with the electrical inspector.